Hi, my name is David, and my inquiry is into the environmental factors responsible for the reduction of water levels in the Gnangara Mound. The Gnangara Mound is a superficial aquifer located underneath the coastal plain north of Perth. It stretches over 2,200 square kilometres and is the largest source of quality fresh water found locally. Nationally recognised wetland and woodland ecosystems, containing unique flora and fauna, rely upon this aquifer for their freshwater needs. Monitoring of the groundwater levels has shown a steady decline since recording began. This places ecosystems under stress as they no longer have access to the water responsible for their creation. Growing up in outback Queensland, water was frequently front of mind, as it's essential for survival and always in short supply. Australia is one of the driest nations on Earth. We have a responsibility to manage water resources or we risk their viability. In order to research this issue, I linked Google Scholar to the Curtin Library. I then searched for journal articles discussing the sustainability of the Gnangara Mound using the search terms listed. Google Search was also used to find technical reports and management plans on government websites. I found it useful to employ Boolean operators in a site-specific search term to narrow the results, as the initial search returned many results that were not relevant. There are three main factors responsible for the water level decline in the Gnangara Mound. These are reduced rainfall, reduced recharge, and increased abstraction. Rainfall is the main source of input into the water cycle. Aquifers rely upon rainfall soaking into the earth to replenish groundwater levels. Ali et al. Explains how the once consistent and reliable annual rainfall patterns, once typical to Perth, have now declined by almost 15%. This is now understood to be a permanent climate shift. Once the rain has fallen, it needs to be absorbed by the earth like a sponge to saturation, so it can trickle down into the aquifer. This process is known as recharging. Urbanisation of the land above the aquifer acts as a barrier because hard surfaces such as buildings and roads prevent absorption. Commercial pine tree plantations also absorb rainfall through their root system before it can reach the aquifer. Abstraction is the removal of water from the aquifer system. The population of Perth continues to increase, and so will the amount of water required by its residents for daily use. The root systems of mature pine trees have also grown deep enough to access the water table directly, further lowering its level. We can see in Figure 10 how many gigalitres have been removed from the aquifer since measurement began in 1979. To ensure the Gnangara Mound's sustainability, water removed from the system must not exceed what enters. Equalising this imbalance can be achieved by finding alternate sources of water and reducing the amount of water taken from the mound. Whilst control of the weather is beyond our means, new water sources have been developed to offset the reduction in annual rainfall. 2 new desalination plants are now responsible for providing 47% of Perth's fresh water. Wastewater is now recycled and injected into the aquifer. This restores groundwater levels and allows for water to be stored for future needs. Improved urban design can direct rainfall runoff into areas where it can accumulate and be naturally absorbed into the aquifer. The commercial pine tree plantations are set to be removed by 2028 and transitioned back into native bushland. This move alone will increase absorption and decrease abstraction. Public education campaigns are designed to educate residents the need for water conservation and encourages the use of water-efficient devices. This inquiry is best related to Year 6 students. Students in this year are exploring cause and effect relationships and how they impact the development of living things. Students also begin to view the Earth as a series of interconnected systems where the changes in one area can affect another. Specifically, that the abundance of life in a particular system is dependent upon the level of change it receives.